Here I have a question. Evaluate for the given derivative. d by dx of square root of sine x plus square root of sine x plus square root of sine x, and so on, repeated for infinitely many times. I would like to thank Swapnil from India for the suggestion. This is a textbook problem in preparation for the JEE Advanced, which is famously one of India's hardest tests. In this video, I will show you two approaches to solve this problem, and at the end of this video, I will share a trick to solve these types of problems, so keep watching till the end to know the solutions and the trick. So here's the first approach. We will first let the given function be equal to y. Next, we will square both sides to get y squared equal to sine x plus square root of sine x plus square root of sine x, and so on. Now, on noticing this, we can clearly tell that this is actually equal to y that we assumed earlier, so we will substitute that in. Now, we will take the derivative of both sides with respect to x. Next, we will split derivative of sine x plus y into derivative of sine x plus derivative of y using the property displayed above. In the next step, since we cannot differentiate y squared with respect to x, so we can apply the chain rule displayed above to get dy squared by dy into dy by dx and copy down the remaining terms. Further, the derivative of y squared with respect to y can be calculated as 2y using the power rule displayed above, and the derivative of sine x is cos x. Next, we will transpose dy by dx from RHS to LHS. Then we will take dy by dx as common from the first two terms of LHS to get a factor of 2y minus 1. Next, we will transpose 2y minus 1 to RHS to get dy by dx equal to cos x by 2y minus 1. Now, from the basic law of exponent, we will write 2y minus 1 as square root of 2y minus 1 whole square. In the next step, we will expand 2y minus 1 whole square to get 4y squared minus 4y plus 1. Then we will take 4 as common from the first two terms to get a factor of y squared minus y. Now, on having a closer look on the second step of our solution, we will come to a conclusion that y squared minus y is actually equal to sine x. So we will substitute this in our current step. In the final step, we will substitute the value of y that we assumed in the beginning to get the required answer of derivative of square root of sine x plus square root of sine x plus square root of sine x, and so on, equal to cos x by square root of 1 plus 4 sine x. Now the second approach. In this method, our first two steps will be same as the previous method, so we will copy it down from the previous slide. We will now begin by transposing sine x and y to LHS to get y squared minus y minus sine x equal to 0. Now we need to solve for the roots of this quadratic equation in y. We can do that by Brahmagupta's quadratic formula. We substitute in the values, and then we simplify. We get y is equal to 1 plus minus under root of 1 plus 4 sine x all over 2. So we will use this as our next step. Now, since y is a square root function, it must be greater than or equal to 0. Therefore, we can eliminate the possibility of being y is negative. Next, we will differentiate both sides with respect to x. Next, we will rewrite the terms in the bracket as 1 by 2 into 1 plus under root of 1 plus 4 sine x. Now, since 1 by 2 is a multiplied constant, so we can factor it out using the property displayed above. Next, we will split the derivative of 1 plus under root of 1 plus 4 sine x into derivative of 1 plus derivative of under root of 1 plus 4 sine x, using the property shown above. Now, the derivative of a constant is 0. Therefore, the derivative of 1 is 0, and hence we can eliminate it. Now, since we cannot differentiate under root of 1 plus 4 sine x with respect to x, so we will apply the property of chain rule, displayed above. Doing this gives the following terms. Next, we will rewrite under root of 1 plus 4 sine x as 1 plus 4 sin x whole raised to the power of half. Now again, we will split derivative of 1 plus 4 sine x with respect to x using the previous property. And once again, derivative of 1 will be 0, so we will eliminate it. Now this can be simplified using the power rule displayed above to get 1 by 2 times 1 plus 4 sine x all raised to the power of 1 by 2 minus 1. We will also simplify 1 by 2 minus 1 as minus 1 by 2. Next, the derivative of 4 sine x can be written as 4 into derivative of sine x using the property discussed earlier. Next, the derivative of sine x is cos x, so we will substitute that in. Now, on further simplification, we get dy by dx equal to 1 by 4 into 1 by under root of 1 plus 4 sine x into 4 cos x. Next, we will multiply the numerator and the denominator to get 4 cos x upon 4 into under root of 1 plus 4 sine x. On cancelling out 4, we will be left with dy by dx equal to cos x upon under root of 1 plus 4 sine x. Finally, we will substitute the value of y that we assumed in the beginning to get the required answer of derivative of square root of sine x plus square root of sine x plus square root of sine x, and so on equal to cos x by square root of 1 plus 4 sine x. Now here's a trick to solve these types of problems. So consider if y is equal to square root of fx plus square root of fx, and so on repeated for infinitely many times. Then derivative of y with respect to x is equal to derivative of fx upon square root of 1 plus 4 fx. Now we will see some examples to understand this trick better. So the first one, if y equals square root of tan x plus square root of tan x and so on. Then dy by dx equals sec squared x upon under root of 1 plus 4 tan x. The second one, if y equals square root of cot x plus square root of cot x and so on. Then dy by dx equals minus cos x squared x upon under root of 1 plus 4 cot x. The third one, if y equals square root of x plus square root of x and so on. Then dy by dx equals 1 upon under root of 1 plus 4x. Thanks for watching, and please don't forget to subscribe my channel for more such thrilling videos.